geometry and Beer-Lambert's law, stating that there is a linear correlation between the absorbance and concentration of an element. The element we were working with today was copper 2 sulfate. What we did was we wanted a ratio of 1 to 2 every single test. So we started out with a stock of 0.32 moles, and that's the unit we're going to be using today. We went from 32 down to 0.16, 0.08, 0.04, and finally 0.02, and we measured the amount of absorbance from each level. There was also an unknown variable, which we will figure out in the end, but basically we did this by using a spectrophotometer. That's the first time I actually said it right on the first try. That's a tongue twister. Anyways, so we used a spectrophotometer to measure this absorbance from each level. And what we had to do was we had to create let's see, where is it? A standard curve graph, which is the way of measuring these dilutions and the way they go. So let's see here. So this was my graph that I made with the serial dilutions. Basically, this graph right here does not include the unknown variable. But what I did was I found the best fit line through an equation that the chart did for me, and I set it up something like this. Let me find it real quick. This is a long and oh my gosh, there we go. So I used the best fit line, and I started off the y as the absorbance. The absorbance of the unknown variable was 0.09. So basically I shifted over the b variable onto this side, so it became positive. I added that to the absorbance, and all we had left on this side was the slope. So afterwards we take the slope and we divide it by the absorbance plus the v variable, and we get the unknown variable of 0.1361. All right, so something that's kind of embarrassing is that I'm really hard-headed and I didn't realize there was a best fit line. So I really spent about 4 hours looking up and trying to figure this out with the margin of error that was included in the spectrophotometer. And yeah, so it is 0.13614 plus or minus a margin of error of 0.0432 or 52. Yeah, that's probably why I'm not going to be I'm going to remember this for the best reasons. But yeah, basically this experiment, also we had to do the post-lab question of trying to figure out why this graph was wrong. And you know, we had to point out the stuff like that. The graph isn't linear, the line isn't linear, it doesn't show correlation, there's no axis title, vertical title, and the horizontal title is not that descriptive. I kind of forgot something, but back to the experiment, we did use cuvettes, and that's something I haven't really seen before. Cuvettes are kind of like mini squared test tubes that we used to put the solution in, because the way the spectrophotometer works is that it measures the absorbance through light, and it uses the light of photons to get there. So basically, the less amount of fluid in there, or the copper 2 sulfate, the more see-through it'll be, the more light it'll be able to absorb, or the more light it won't be able to absorb, and that's what the spectrophotometer picks up. Let's see. As we can see, there's a clear correlation going from top to bottom on how the absorbance heavily falls off. And even with the unknown sample, even though it was 0.136, you could still see a clear distinction between that and the 0.32. Overall, definitely it was a pretty interesting experiment, even though I accidentally made it take about 6 times as long because I didn't want to read the full instructions. But definitely was a learning experience, and it was pretty cool. Like, I just like working with these type of chemicals in general. You know, I've always had a love for it. But yeah, thank you and have a good day.